Hello everyone, my name is Xinyi Li. Today I'm gonna to talk about the project in my system engineering class and my midterm report, Analyzing Air Traffic Control System. In this presentation, there will be four main parts: introduction, background, concept development stage analysis, and challenges. So now let's start from the introduction of system engineering and the project. A system can be seen as a set of interrelated components working together to reach a common goal. System engineering aims at the realization of successful complex systems by interdisciplinary approaches based on the consideration of whole system. It will focus on the defining the needs of customers and defining the required functions in the development cycle, and then documenting and proceeding these requirements with design synthesis and system validation. Complex systems like transportation system, automobile system, and many other systems that performs different functions to convenient our life. This project aims at learning system engineering through analyzing air traffic control system. To develop a new system, it should follow the system development process, which contains three phases: the concept development stage, engineering development stage, and the post-development stage. This midterm report would focus on the concept development stage in analyzing the air traffic control system, including needs analysis, concept exploration, and concept definition. The next part is background. Before introducing the air traffic control system, I will first talk about the concept development stage in detail. Concept development stage is the initial step at system development process, which would analyze and plan the needs of a new system, analyze the feasibility of its realization, and specify the architecture to best meet the requirements of users. It contains three phases: needs analysis, concept exploration, and concept definition. Air traffic control was first used in Croydon Airport in London at 1920. It is a service provided by airport to make direction for the aircraft in controlled airspace and give advices for the aircraft in non-controlled airspaces. Air traffic control system is a typical system that requires system engineering. It is constituted by air traffic control tower, like the picture, and an area control center. Air traffic control tower perform the primary controlling of the immediate airport environment by visual observation and controllers. It is assembled by several components, including radar system for traffic approaching and departing, ground control system to control the movement areas such as taxiways, inactive runways, and holding areas, an air control system to ensure the prescribed runway separation could exit at any time. Meanwhile, the Area Control Center provides the clearance and instructions for aircraft in and out. It contains components like Air Traffic Control Center to give instructions to pilot, another radar system to ensure the airspace coverage and flight traffic mapping. So now, image, if we want to design an air traffic control system, we should start from the development stage. First, we need to analyze the needs of customers. I have divided these needs into three parts. First is marketing needs. After the widely use of airplane in transportation, air traffic control is necessary for ensuring an orderly and safety taking off and landing in airport, which not only save time but also improve the working efficiency by avoiding congestion in airport. Also, air traffic control can be used to avoid collision among large amounts of aircraft in the same airport, which can provide a safety environment. Second is the security analysis. With the increasing terrorist attacks related to aviation activities in recent years, we need air traffic control to represent the role of security and defensive. So if air traffic control system detects some abnormal aircraft activities in their airspace, they can contact government or military as soon as possible. Finally is the technical needs. The old air traffic control was done by using different colored flags to instruct the aircraft, while in 1950s, after the radar and radio system has been widely used, the modern air traffic control system should be upgraded with this new technique, so the controller can communicate with pilot by radio and the radar system can provide a much wider coverage of airspace. The second phase in concept development stage is concept exploration. With the above needs analysis, air traffic control system can be defined as a system that provides organization for the traffic in their airspace, like control the order of landing and taking off, and control the space between aircrafts, and also perform the defensive when attack happens. This big system can be divided into two main subsystems. One is a visible control center, which can directly see the airport to provide primary instructions for the aircraft taking off and landing. And another one is a local control center, which ensures the airspace coverage and can map the flight in their airspace. In order to achieve the function of visible control center system, some requirements should be considered. First, this center should be built in or close to an airport to have a complete view of the airport. Thus, a tall tower with large windows would be the best choice. Then, to provide instructions to aircraft, there should be controllers communicate with pilot through wireless radio. And the radio system should be good quality and less affected by interference. Apart from the controllers, there should also have approach and terminal control system, which is responsible for control the altitude of aircrafts after they take off and ensure an appropriate landing rate when they are landing. Also, the control center should be configured with a radar system, so it can provide aircraft location information to the controllers. In addition, the control center tower should collect the data of aircraft in the ground before they take off and make sure the clearance of the flight route to avoid a collision between aircrafts. In local control center, it should be compiled with the radar system to map the flight in airspace, which can ensure the space is big enough between aircraft to avoid potential congestion. Also, it could prevent aircraft's inroad by mistake from other airspaces or interfering with the flight route. Apart from that, local control centers should also deal with emergency requests like supporting pilot or contacting hospital. The last phase is concept definition. After the concept exploration, the functions of subsystems and their components of the air traffic control system have been clearly stated. To meet the requirements of air traffic control system and in the consideration of operational cost and risk, some concepts should be selected from concept exploration. As well known, the most basic and important function air traffic control system should be the ability to organize and control the air traffic flow in their airspace. Thus, the radio system and radar system are necessary to communicate and detect. The technique for building these two systems is mutual and the cost is relatively low compared to developing new technology. Thus, wireless radio system for communication and radar system for detection should be configured. The traffic control tower is also important as it provides the working environment. Building a tower costs a lot, thus the location of tower, the height of tower should be considered carefully. Approach and terminal control are necessary as they ensure the safe and successfully taking off and landing for aircrafts. As the ground aircraft's control can provide an orderly control for aircrafts waiting for taking off in the airport and make sure there will be no collision between these aircrafts. The local control center should be selected as a subsystem for the air traffic control system. Also, the ability to deal emergency is indispensable in the airport. Finally, I'd like to talk about the challenges met in designing air traffic control system from traffic volume, weather, and technique. When an aircraft lands down, it will first touch down, slow, and then exit the runway before next aircraft land, which would need about 1 to 4 minutes. However, there are up to 5,000 airplanes per hour in the United States at rush time. Even the large airport might cannot handle such large traffic. Thus, delay occurs every day. Adding more runways or building larger airports seems to be good solutions, while the cost and the time needed would also be large. Thus, how to balance the increasing volume of traffic with the limited capacity of air traffic control system should be a considerable challenge in the future. Weather is another important factor that impacts the traffic capacity. Aircrafts need more time to land in bad weather conditions like rain, snow, and it also needs more space between aircraft to avoid collision, which would cause the ground delay. Sometimes extreme weather conditions would even cause some serious safety problems when landing and taking off. As a result, how to minimize the loss due to bad weather could be a challenge to engineers. As mentioned before, air traffic control uses wireless radio and radar system to realize control function. Although these two technique systems have been development for many years, there still exist some risks. For example, extreme weather condition could affect its stability, which would cause unstable connection between aircrafts, and the cost for maintenance is also high. Building a successful air traffic control system and put it into use need a lot of money and time. Thus, each step in designing should be careful to avoid wasting. Composing each component in subsystems and then making them up to a whole system is difficult, as it needs to ensure each component work together without problems, and also ensure each subsystem works very well with each other. So engineers should consider the risks as early as possible in development stage. In conclusion, development process in system engineering mainly refers to the revolution of a new system when its needs are required and the technical approaches are identified. This report focuses on the concept development stage in analyzing their air traffic control system from needs and analysis, concept exploration, and concept definition. And finally, challenges for engineers in this development process are listed and discussed. In final report, apart from the content discussed in this report, the other two system development stages, including engineering development stage and post-development stage, will be analyzed. So it's all of the presentation today. Thanks for your watching.